Welcome to the lecture on special casting processes. In this lecture, we will discuss about different casting processes like low pressure die casting, vacuum casting, Crosworth process, squeeze casting or Tixo casting, Rheo casting, etc. So, what for this low pressure die casting is required? Now, what we have seen that in the case of die casting, where the metal is subjected to the die cavity under a large amount of pressure, and that pressure is basically held for certain duration to ensure that solidification takes place under pressure, and then the pressure is released, the dies are separated and the cast product is taken out. Now, in this case the pressure requirement is less. So, that is why it is known as low pressure die casting. So, here the process is adopted in such a manner that the pressure requirement is less. Now, what happens for metals like aluminum or magnesium, the requirement is felt only because when you apply large pressure, then there is possibility of formation of vortexes or turbulent pockets. Now, for metals like aluminum or magnesium which are highly oxidizable, so if under the pressure the metal is subjected to turbulent behavior or turbulent conditions, then that may lead to formation of oxides and that will spoil the quality of the cast product. So, a process is thought in such a manner that this turbulent entry of the metal into the cavity should be minimized. So, for that what happens when you have to, because in the earlier cases when you have to go for thin sections casting, you will have to apply large amount of pressure, and that may lead to formation of vortexes and turbulent conditions. So, in this case the pressure is applied, but then the metal entry is from the downward to the upward direction. So, by the upward displacement of molten metal from a sealed melting pot or bath. So, what happens, you apply the pressure on the side walls and in such a manner that when it presses, the middle portion which is having a tube, from there from the inside, due to this pressure the metal goes, and at the top you have the die cavity where the metal enters and you get the cast product. So, in this case the pressure level is 0.5 to 1 kg per mm square. So, it will be something close to 50 to 100 kg per centimeter square. So, dies are filled with ample of venting, so that there is escaping of air allowed. You see that air should be escaped if any air comes into it, or if the die has already certain air, it should be able to go out. Upward filling requires no runner and riser, so no loss of the yield. So, what happens, because there is the upward movement of the liquid from in the mold. So, what happens, there is no requirement. So, simply it goes into the cavity, no need of the sprue or the riser or the runner. So, in fact that improves the casting yield. So, no loss of yield, basically it is yield, there is no loss of yield, as there is upward movement of the molten metal directly goes into the cavity. There is, because in the earlier case you had the formation of sprues and all that, in this case there is nothing as such. So, that yield is improved. As we discussed, the presence of low pressure eliminates the turbulence and air aspiration. So, as the pressure will be more, if the at higher velocities or at the corners, there are chances of formation of turbulent pockets, and then the presence of these turbulence and the formation of the adverse pressure gradient situations that may lead to the aspiration of air. So, basically that will contaminate the melt pool, especially for those metals which are highly prone to getting oxidized. You can use the cores if there is requirement of core to be fitted. So, this method is used for manufacturing of automobile and aircraft components, impeller for pumps etc. So, for these materials you use this process. Dies are preheated maybe close to 250 degree centigrade, and holding down pressure on dies is there, because you have to maintain the pressure, and that pressure is about 30 kg per mm square. So, that is pneumatically generally applied, because till that time it gets solidified, you have to hold it because you are pressing from the bottom. So, you have to clamp from the top. So, you have to hold it from the top, and the cores can be of sand or shell mold or of the plaster of Paris. So, that is shell. So, this is the example of low pressure die casting. In this case, what we see is that you have the cavity here. This cavity will be filled by the pressure you are applying from this side. This pressure goes and this presses at this surface. So, once it presses on this surface, the liquid metal comes down, and that will try to provide a shift in the upward direction. So, metal goes due to this pressure. So, it goes directly here. So, in under that small pressure it will go there and it will go into the cavity directly, and these are the dies which are clamped, which are basically having certain pressure from the top. So, they are holded at its position, and you get the product which goes into it, it gets solidified, and then you can take the dies, the two halves of the dies out, and you can get the material out. So, this way you use this low pressure to get the cast component. Another variety of the casting process is vacuum casting. As the name indicates, here the feeding of the metal is because of the formation of vacuum. So, once there will be movement of certain part, that movement will induce the vacuum, or you create the vacuum using certain pump. Then because of the vacuum, the molten metal goes into that portion where the vacuum is created, because metal will flow from the higher pressure regime to the lower pressure regime. So, the metal goes, and under that metal goes into the die cavity. So, evacuation of die cavity is aimed at reducing porosity, assisting flow in thin sections, and improving finish while reducing injection pressure required. So, basically as it goes under vacuum, so there is no chance of going any air into it or gases into it, that reduces the chance of any porosity which may be formed. It can go into thin sections because it is all going everywhere because of the vacuum created. So, that ensures the presence of vacuum at any point ensures that that portion will be filled by the molten metal, and that basically helps in getting the very fine details on the cast product. So, injection pressure is also less. Vacuum employed to fill chamber through a suction pipe from holding furnace below. So, you have on the bottom side you have a holding furnace, and that from there the vacuum is implied through a pipe. So, this is how it goes. You have this mold, and in that once you create the vacuum, once you create the, so you have certain mechanism by which you can create the vacuum. So, once the vacuum is created, you have the pump attached. So, from there you can create the vacuum. Once the vacuum is created, the molten metal will enter into it. So, that will molten metal will go inside, and it will go into all the cavities. So, molten metal, so there is no contact of molten metal with air. So, it is directly going from there into the cavity, and that is why the chances of having impurities or porosities, they are quite less in such cases. Crosworth process. Now, Crosworth process is based on a pump known as Crosworth pump. So, it overcomes the problem related to entry of turbulent metal into the casting furnace. So, what happens when you give the molten metal into the casting furnace in a turbulent manner, then there is chance of the dissolution of atmospheric gases or dissolution of air into the melt, and that basically will spoil the quality of the melt. So, here metal is allowed to stand in holding furnace and then transferred by means of a pump without moving parts into a resin bounded sand from below, displacing air progressively. So, what happens? You have a holding furnace that is here, and then this is the holding furnace. So, melting furnace is here, it will come here, and then there is a Crosworth pump. So, that is a pump. Because of this pump, it will this metal goes into this mold. So, without moving parts, and it will go into a resin bounded sand from below. So, this is the resin bounded sand, and the melt will travel from here to this resin bounded sand. So, what you see is, since the melt is not at all exposed to the atmospheric air or in any way it is not exposed. So, from here it goes through that Crosworth pump which has non movable parts. So, it will take this liquid metal through this channel and it will go into this resin bonded sand, and here when it comes into contact with this molding material, that is resin bonded sand, it will. So, this is the zircon sand mold which has quite a good conductivity. So, as compared to the silica sand or other sands, then in that case it gets solidified and you get a clean kind of product. So, based on this, the use of this Crosworth pump, this process is known as, because it also uses very low pressure and the metal entry is from bottom to top. So, this gives a clean kind of cast product. So, that is known as Crosworth process. Next type of casting is squeeze casting. So, as the name indicates, here some squeezing action is implied. So, this process is a combination of gravity die casting and closed die forging in a single operation. So, what happens in this process? What we see is, in the gravity die casting, what we had seen is the dies are closed and then you are pouring the liquid metal enters into the cavity under the action of gravity. So, that is why that is a case of gravity die casting. Closed die forging. So, closed die forging, it is a forging process. Forging process is nothing but applying the compressive forces on any product under the closed dies. So, dies will be meeting each other and then they will apply a pressure on the product, so that the metal which has been put in, it will ultimately follow the contour of the cavity. So, that is closed die forging. So, die forging basically is of two types, one is open and one is closed die. In the open die forging you have the flat surface. So, that is not the case here, it is a closed die forging, means there is cavity engraved in the dies, just like you have the die for these die castings. So, there also you have different dies, you have bottom die and top die. Bottom die is fixed and top die moves, or you may have even both die moving I mean depending upon the situation. But in this case, so basically this method is the mixture of or the combination of these two processes. So, where what happens, so it is also known as liquid forging, a hybrid metal forming technique. Liquid forging means the forging process is carried out when the metal has certain liquid fractions. So, what happens in case of forging, what we do is you are heating the material to certain temperature, it has not gone to the liquid state, but here not completely liquid state, but you are basically first of all putting the material in the liquid state and then you are pressing. So, that is why in the liquid state itself you are applying the pressure, that is why it is known as liquid forging. So, it is producing a near net shape component in metals, alloys and composites. So, if you look at the process, you see here you have a hydraulic press and you pour the liquid metal into the mold, and then from the top this punch portion, this is the die and this is the other half of the die. So, you have to make such kind of cavity. So, from the top, once you have poured the liquid metal into it, you put this upper die portion and then you apply the pressure over here. So, this liquid which is there in this mold, under the action of this pressure it gets solidified, and it solidifies in a very small amount of time, and this type of technique, because you are forging in the liquid state, normally the forging is done for the solid product, for the solid pieces. So, but they are heated, maybe hot forging or cold forging may be carried out at different temperatures, at higher or lower temperatures, but in this case this is liquid and then you are applying this pressure from the top. So, that is squeezing the metal in mold and maintain the pressure. So, that is why it is known as squeeze casting. Then you are taking this die out or this punch out and then you are ejecting using the ejecting pins this finished casting. So, that is taken out and this way the process is carried out. So, what are the advantages? Because you have the liquid state itself, there you are applying all the pressure and get the solidified product. So, the chances of formation of any gaseous pocket is minimized. So, because these gaseous pockets are likely to form when there is gradual transformation from liquid to solid state and there is no scope of the air to go out, but here all on a sudden on the liquid itself you apply the pressure. So, there is no time in between the transformation process, all these processes occur simultaneously and the shrinkages and porosities are all negligible. You have fine grained structure because the top die, that is punch, which moves from top to bottom, it is at lower temperature. So, the undercooling experienced is quite high and that is why you get quite a fine grained structure. You do not have any requirement of gating or risering. So, because of the absence of gating or risering requirements, the yield is quite high. So, in the case of other castings like gravity die casting or so, you are giving the extra metal which is basically a part of the cast product in the form of sprues, runners and risers. Now, here you do not have that, you have the punch or the upper die, it has the shape. So, according to the product shape or the shape of material which you are likely to get. So, you are directly getting that. So, once you remove the pressure then you are getting the product. So, that is why because of not having any gating and risering, your casting yield is quite high. Better mechanical properties, as the material will have fine grained structure and also it will be free from shrinkage and porosities. So, once you have fine grained structure, the properties will be better. The fine grained structures produce good tensile strength or strength based on certain formulas which tell that because of the fine grains your strength of the material is higher. One of the formula is Hall-Petch relation. So, because of that you get a better mechanical properties. Near net shape manufacturing capacity. So, basically what you see is in one go itself you are getting completely near to the net shape. So, then you do not need to go for further machining of the object, you are getting the final product shape in one go itself. Now, what are the process parameters? So, process parameters are like pouring temperature, melt volume, tooling temperature, melt quality, time delay, pressure level and process duration. So, basically you will have to maintain a balance to see that there is proper amount of these controlling parameters or there is proper level of all these controlling process parameters, like pouring temperature or melt volume has to be adequate, so that it does not, when you are basically putting in the cavity. So, during that process it should not lose the superheat, the temperature should not come down. Basically if the temperature comes too much of down, in that case you may require large pressure to be applied. So, once its temperature comes down, the requirement of the pressure to be applied from the top die or the punch, it will be quite high. So, your pouring temperature has to be adequate. Similarly, melt volume also has to be properly controlled. If the melt volume is less, then there will be underfills, the cavity will not be completely filled, and if it will be more, then there will be losses, it will go as splash, or if not, then it will create a large amount of pressure. So, melt volume has to be controlled. Tooling temperature, so means you are basically keeping the temperature. So, die temperature is something close to 190 to 315 degree centigrade, and then this punch temperature will be kept 15 to 30 degrees C below this die temperature. So, this way you have to maintain the temperature of the melt. Melt quality, like melt should be free from any kind of impurities, dirt or so. So, because if it goes inside the cavity, it will try to be trapped into it and that will spoil the complete casting. Pressure level has to be maintained maybe from 0 to 75 megapascal, and you will have also the duration, that is normally 30 second to 120 second. The thumb rule is 1 second per mm of section thickness of casting. So, that is the duration of the process. So, this is how we have seen that this is squeeze casting. There is another kind of metal working process or casting process, it is known as semi solid metal working process, because here what happens, you see that it is a kind of, because we also do some working on it, some forming process goes on, some pressure we apply, that is why we also call it as semi solid metal working process. Now, its varieties are many, and one of them is Rheo casting. So, what is Rheo casting basically? So, in that case what happens, you now in this case, in this semi solid metal working process, the aim is to avoid the dendritic type of structure, and you try to see that you get favorably equiaxed globular structures. Now, what is that process which induces all that? So, the Rheo casting is there. In the Rheo casting, basically what happens, the melt is there which is agitated by the impellers or multi-paddle agitators. So, there is melt, in that you have impeller or agitator which is revolving inside the melt. Now, and also it is getting cooled. So, what happens, there is formation of the spherical or from the particles, and being an alloy it will try to have dendritic arms, but because of the continuous stirring and agitation these dendrites are broken. So, ultimately what you get is this, because of the shear the dendritic structures are gone and the non dendritic type of structure is formed. So, the processing variables are shear rate, cooling rate, stirring time and volume fraction of solid. So, these are the processing parameters which basically control what way you can get what kind of structures. So, basically in this, as the time moves and as these variables change, the shift from the dendritic structure to the equiax structure will be observed, and because of the breaking of these dendrites. Another kind of this process is Tixo forming. So, Tixo forming is based on the thixotropic word, which is nothing but means that that because of the shear material flows, but it thickens when standing. So, when it is standing it is thick, but once you apply the shear force it will flow. So, it is done between solidus and liquidus temperature, and basically for that these are the processes which are used for further Tixo forming or Tixo casting of the product, and that is MHD casting, where the DC continuous caster is there and you apply the magnetic field, and because of that these dendritic structures are avoided. Because of the continuous rotating magnetic field in the continuous caster, there is avoidance of the formation of dendritic type of structure. Similarly, strain induced melt activation, where it is hot worked and cold worked and then kept into the range of solidus plus liquidus. So, because of the high angle grain boundary formation, on that concept this strain induced melt activation is there, then you cast. So, you get a fine structure, and then there is spray casting, where the metal is melted and sprayed through a nozzle, and then it once it goes on a surface substrate, then there it takes in a certain shape, that is spray casting. Then these products are going for getting Tixo cast or Tixo formed. So, these are the semi solid metalworking processes which are there in the practice, which are the basically future generation metalworking processes or casting processes which are used, although they are little bit costly because of the presence of the equipments which are costly, but they give you very good quality products. Thank you.